Very warm welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Currently we are in the third module where we are studying different materials and manufacturing processes. So in this lecture, we are going to study what are the different joining processes that are related to welding. In the previous lectures, we have seen what is soldering and brazing. So soldering and brazing are the techniques which are used for metals which are very thin, and the techniques soldering and brazing will form very weak joints. Now when we start about the process called welding. Welding is a process where strong joints are formed. So if I want to join two metal plates, I have to use this technique called welding. When this welding can be applied, welding is possible only when the plate thickness is above 5 mm. Below 5 mm, we have to go for other techniques like brazing, or if the thickness is very low, we should go for riveting or other techniques like spot welding. So only when the plate thickness is about 5 mm, we should go for welding. Welding, there are different techniques. And in welding, the joint that is formed will be as strong as the base metal. Suppose if I have two plates, these two plates are joined at this location. At this junction, they are joined, welded together. Now what happens? The actual strength of these two plates, plate 1 and plate 2, will be different. Even though they are made up of same kind of material, the strength will be somewhat equal, and sometimes it is different. Now, what about the junction or the joint that is newly formed? So, the joint that is formed using the technique called welding is same as the strength of this junction is same as the base plate. So, welding is the best technique to join two metals. It forms a permanent joint which is as strong as the base metal. Now, there are different techniques of welding. Now let us see one such process, that is oxy-fuel gas welding. So oxy-fuel gas welding is a technique which uses oxygen and combined with a fuel, that is some kind of gas is mixed to form the heat that is required for welding. So apart from these two gases, we are using some other type of filler material. So in every welding, like we have to use a filler material. This filler material will be same as that of the base metal. We have discussed this in the previous brazing lecture. The filler metal is a combination or an alloy of the base metal. Okay, it should be of the same kind of the base metal. Suppose if I am welding an iron plate, I have to take a iron filler rod combined with some other minerals, but it should be the base form should be iron. So, in this manner, we can join two plates by using a technique called oxy-fuel gas welding. So, the main requirements or the apparatus for this process are, we should need a filler rod, filler material, and then we should need some gases, and then we should need some equipment, that is welding torch and etc. So, welding torch is required. So, these are the requirements for the process of this welding. Now, this process is called oxy-fuel gas welding. Mostly, this is the kind of fuel used in this process is acetylene gas. So, along with oxygen, we will use acetylene gas to produce the flame. Now, the most common process is oxy-acetylene gas welding. So, there are three types of flames that can be produced using this different types of gases, or based on the different types of combinations of gases can be used to produce different types of flames. So the first one is neutral flame. So the neutral flame is like it is 50-50 combination of the oxygen and acetylene gases. So we use two gases, oxygen and acetylene. Okay. So based on the compositions or the percentage of composition of these two gases, we can produce a neutral flame. If they both of them are equal, we'll get a neutral flame. And then if the second type of flame is called oxidizing flame, which contains more oxygen than the acetylene. Simply, if the oxygen is more in the composition when the gases are combined in the torch, so the flame that is produced is called oxidizing flame. And then the third one, reducing flame or carburizing flame. So what is carburizing flame? It contains more acetylene than oxygen. So here, same proportion. Here, more oxygen is there. And in the third one, more acetylene is there. So because of these different compositions, we can get different types of flames. So depending on the composition, and we'll get different flames. And these different flames has different applications also. They are not simply manufactured. I mean, they are not simply made and they are used. So depending on the type of metal we have to weld, we should choose a particular type of flame. So out of these three flames, we can simply observe that one flame is very hot, that is oxidizing flame. When the oxygen is more in the flame, the temperature produced is very high. So this can be used for metals like iron, and also when the plate thickness is very high, we can use oxidized flame. If the thickness is somewhat lesser than the previous oxidized flame, we can use carburizing flame. Okay. So, and sometimes we have to use the neutral flame in order to produce a clean weld. Okay. So, we'll see how actually the welding process, that is the gas welding process, actually takes place. So, this is the torch which we are talking now. So, this torch is the equipment that is required to mix the two gases. So, the two gases, oxygen and acetylene, are combined in this torch. And at the end of this torch, these are discharged outside. So, the end of this torch has a nozzle. So, the nozzle is burned with some fire and we will get continuous flame. So, this flame is used to heat the base metal. So, this is base metal and also the filler metal. This is filler metal. So, both of these metals are heated with the help of the heat that is coming from the torch. So, when we talk about the terminology, we have different parts of this. So, they are filler rod, which is nothing but a extra metal rod which is used for welding. Molten metal. So, this is the metal that is melted from the filler rod as well as the base plate. And we have base metal, that is the metal which we have to weld. And then we have gas mixture that is coming out of the nozzle of the welding torch. And then this part is called welding torch. And then we have flame. And then we have solidified weld metal. So when we are welding the metal plate, we will move in some direction, like from left to right. This is right or this is left. From right to left, we have to move. So when we are moving, we have to weld the entire length of the solid plate. So when we want to weld this, we have to move the torch along with the filler rod so that we will form a joint along the length of the particular base plate. So when we are moving in this direction, this area is called as it is already welded and it will be solidified slowly upon cooling with atmospheric air. So this area will be called as solidified weld metal. And in the next picture, we can see a welding torch. So this welding torch is nothing but it is the torch which contains a proper chambers for the combination of gases. So see here, there are two valves attached here. These two valves will operate the amount of fuel or the amount of gas that is flowing through it. So one pipe it is connected to oxygen and another pipe is connected to acetylene gas. So these two are combined in a proper proportion depending on the application. So by operating these valves, we can make the air we can make the gases flow into this welding torch. So we can actually see the cross section of this welding torch. Here oxygen is connected and here acetylene is connected. Okay, these two pipes are combined and they are mixed in a closed cylindrical chamber. So inside this chamber, these two gases are mixed and they are sent into the welding torch tip. and at the tip we can make the gases burn so that we can form a continuous flame. So this is how a welding torch will work. And the rest of the thing, that is the welding equipment, this is the entire equipment of the welding, that is gas welding. We have two cylinders, one cylinder contain oxygen and another cylinder contain acetylene. Okay, these two cylinders are connected to the welding torch, and at the end of the tip of the welding torch we have flame that is coming out, and this flame is used to melt the filler material as well as the base plate. So when we compare how this process is completed, so the welding technique or the welding torch will produce a temperature of about 1000 to 1500 degrees centigrade. 1000 degrees centigrade to 1500 degrees centigrade, the temperature that is created by this welding torch. So this much of high temperature is required for the melting of the metal, the base plate or the weld filler rod. So these two are melted with this welding torch locally. That means if I have to weld two plates, I have to keep this torch at this point first, so that it will initially heat the localized point and the filler rod at the same time, so that the filler rod is melted and it will form a layer on the two plates, so that the two separate plates are joined here. So when I move the torch upwards, so it will form a continuous weld like this. Okay, I have to move the welding torch as well as the filler rod so that I will form a continuous joint. So the filler material will be melted and it will fall on the two base plates and it will form a joint. So this is called gas welding. Now, almost all the processes of welding are similar to this gas welding, but the only source of heat will change. Okay, in this gas welding, the source of heat is gas. That means we use oxygen and acetylene combination for the production of heat. Okay, in other processes, we use electricity, or in some cases, we use a combination of electricity and some inert gas. So, depending on the type of gases or type of source of the power, there are different types of welding. Now, let us see another type of welding, that is arc welding. So, what is arc? It is nothing but it is the spark that is produced by a continuous electric circuit. So, this is most popular welding which we see in the market, like most of the industrial and the domestic applications uses this arc welding only, where a metal electrode is connected to a transformer circuit and it will produce arc when it is touched the metal plate. Okay, so this is how the welding is done using electricity. So these electric arc welding processes are very popular and they are very easy, and nowadays the machines that are used for this electric arc welding, they are made so compact and small in size so that they can be carried from one place to another place easily, and they are also very less expensive when compared to olden days. The welding machines are very less expensive nowadays when compared to olden days. Now let us see what is this arc welding and how this is done. So when we compare the gas welding with arc welding, the source of heat will change. So the source of heat in this arc welding is electricity. We use an electric circuit for the production of a spark. So how does this spark is formed? We know that for a closed circuit, we should have a switch. We have a switch, and then we have a power source, that is plus and minus, and then we should have a positive and a negative points where we have to connect the bodies, so that we will form a circuit, and due to the resistance of the metal plate for which we are doing welding, we can produce sparks. So the spark is produced, spark or arc. So here in engineering, we will call this as arc. This is no longer spark. Whenever I say arc, it refers to spark that is produced due to electric current. Okay. So the process here we are saying is non-consumable electrode type welding. So in this process, we are going to use an electrode that is non-consumable. That means I'll show some figures in the coming slides. So we have to use a electrode which is not consumable, which means it is not consumed while welding. So in some other arc welding types, there are electrodes which are consumable. That is why we have clearly referred that this is non-consumable arc welding. So what is non-consumable arc welding? So here we have an electrode which is positive, and we have a negative pole that is connected to the plates which we want to weld. So these two, when come in contact with each other, what happens? They will form a closed circuit so that the electricity will flow through them. Now what happens when I touch the tip of the electrode to the base plate and I remove slowly? It will form some resistance in the air. So this resistance is the key thing to form a spark. Okay. So in this process, the electrode is not consumable, which means we have to use a separate filler metal. Okay. Now we'll see what are the basic things that are required for this arc welding. So in non-consumable electrode welding process, the electrode is typically tungsten electrode. The electrode is made up of tungsten, and because of this high temperature involved, an externally supplied shielding gas is necessary to prevent oxidation. So in this process, we have to use a separate shielding gas to prevent oxidation of the freshly made weld. So the freshly made weld which is in contact with atmospheric oxygen, it will get oxidized and it will be corroded easily. So that is why we have to protect the newly formed joint in order to protect it from atmosphere. And then direct current is used for this welding process. In strike polarity, also known as direct current, electrode negative, the workpiece is positive and the electrode is negative. So in strike polarity, the workpiece is positive and the electrode is negative. And in some other cases, the electrode is negative and it produces a narrow and deep weld. Okay, depending on the type of application and depending on the polarity of the particular welding, we will get different types of welds. Okay, so see here in reverse polarity, that is where electrode is positive and the workpiece is negative. Okay, here we will get a shallow joint. A shallow joint is formed. Okay, we have to compare these two, one in forward direction and another one is in reverse direction. So in forward polarity, we will have thick welds. In reverse polarity, we will have shallow welds. So let us see this arc welding process, that is non-consumable electrode type, where it is called as tungsten inert gas welding, because the tool we are using here, it is made up of tungsten, that is the electrode, and we have to use some form of inert gas in order to protect the newly formed weld joint from oxidation. So this is I stands for inert gas, so G stands for gas simply. So in AC current method, the arc pulsates rapidly. This method is suitable for welding thick sections and for using large diameter electrodes at maximum currents. So we can see in this picture, there are a electrode, this is electrode, and we have a plate here. And then we have a filler rod. So when we see all the parts, we have in this gas passes is there where we will produce or we will send the gas to flow onto the joint, and then we have filler wire which is belted onto the surface of the base plate, and then we have molten weld metal that is just welded because of the heat that is coming out of the electrode, and then we have electrical conductor which is connected to the transformer, tungsten electrode, shielding gas which is used to protect the oxidation of a newly formed weld, and then we have arc. So this arc is nothing but the spark that is produced due to electric current. And then we have solidified weld metal. So the solidified weld metal is nothing but when the electrode is traveling throughout the surface or the length of the metal plate, it has to undergo some form of heat. So when the heating is done, the metal plate will be melted and it will form a solid. So whatever the molten metal that is formed will be solidified due to the atmospheric contact. So this is called as solidified weld metal. So what happens? How the welding is done? So this is non-consumable electrode welding. So here we have to have a AC or DC welding machine, Along with that, we have to connect a inert gas. So this inert gas is used to protect the freshly made joint from oxidation. And then we have this base plate. This base plate is act as cathode, and sometimes, and then we have this electrode. So all these things will help us in order to weld the joints. Okay. So this is the basic equipment that is required for welding. So now when we see another process, that is gas tungsten arc welding. So this is also very similar to the previous method, where the previous method is TIG, TIG, and this one is GTAW. So the basic difference between these two is it is previously called as TIG welding, where tungsten inert gas welding. Nowadays it is being called as gas tungsten arc welding, because the gas we are using here, and the tungsten stands for, T stands for tungsten, and A stands for arc, and W stands for welding. So this is a modified technique. That means the TIG is modified now and it is being called as GTAW. So in tungsten arc welding, formerly known as TIG, the filler metal is supplied from a filler wire. Because the tungsten electrode is not consumed in this operation, a constant and stable arc gap is maintained at constant current level. And then the filler metals are similar to the metals to be welded, and flux is not used in this process. So whenever we are using this process, we should not use flux, because there is no need of flux here, because we are using the inert gases to protect the freshly made joint. And welding with GTAW may be done without filler metals, for example in the welding of close fit joints. So we can make different joints using this GTAW process. Okay. Now let us see, depending on the metals to be welded, the power supply is either DC at 200 degrees, 200 amperes, or AC at 500 amperes. So depending on the type of weld we have to form, we have to choose DC current or AC current. In general, AC is preferred for aluminum and magnesium. So when we are doing welding for aluminum or magnesium metals, we have to choose alternating current, because the cleaning action of AC removes oxides and improve weld quality. So whenever we are using alternating current, it itself acts as a cleaning mechanism, or it helps the oxidation to protect itself from oxidization. Okay, the welding joint will not be oxidized if we are using alternating current. Thorium or zirconium may be used in the tungsten electrode to improve their electron emission characteristics. So we have to add some other metals like thorium or zirconium to improve the electron emission characteristics of the tungsten electrode. So tungsten is a very hard metal. When electricity is made to flow through it, it will produce electric arc. In order to improve its characteristics, we have to add some other metals like thorium or zirconium. And the power supply of this GTAW ranges from 8 to 20 kilowatts. So from 8 kilowatts to 20 kilowatts, depending on the application or the size of the plate which we are welding, we have to choose the particular welding power supply. And then contamination of the tungsten electrode by the molten metal can be a significant problem. Therefore, contact of the electrode with molten metal pool should be avoided. So whenever we are doing this arc welding, see in this picture, so whenever we are using a GTAW, that means gas tungsten arc welding or TIG welding, we have to see that this electrode, which is made up of tungsten, it should not be in contact with this filler metal. This filler metal, what happens when it is heated? It will be simply melted. Now, this molten filler metal should not come in contact to the torch, welding torch. Why? Because it will contaminate the actual properties, or it will form a layer on the tungsten electrode, so that the tungsten electrode cannot produce a arc properly. So that is why the contact of the electrode with the filler metal, it has to be avoided. Now, This is all about the GTAW, and we will meet in the next lecture with the different types of other welding techniques. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.